I introduce you to the Kanu Fin. Our project this semester was to design a product that prevents capsizing or tipping over in a canoe. This product would be especially prevalent in this region because of the cold Idaho waters. Our client Randy King recently purchased a new canoe that is narrower and shorter than what he was accustomed to. He decided to take his boat out on the river one day with his friend, and a sudden quick movement was all it took for them to become swimmers. Randy then brought us his own proof of concept model, which through his testing and experience provided a little extra stability. Our job was to fine-tune his prototype and add additional features and improve it in all areas, making it more suitable for the market. We tailored this product around a few important customer needs. It needed to be universal to canoes of all shapes and sizes, quick and easy to install and remove, height adjustability for various depths of water, cost efficient, and most importantly, to stabilize the canoe. And this is the final product we created. The Kanu Fin offers a sleek design with an optimal fin shape and size to provide the best in-water stability while staying clear of the user paddling. The mounting bracket allows the Kanu Fin to attach universally to all canoes. This is done with a C-channel-like aluminum piece that hooks over the edge of the canoe and is secured in place with a bolt, as can be seen. Attached to the mounting bracket is a clamp that allows height adjustment depending on the amount of weight in the canoe and depth of water. Two plastic blocks are squeezed together against the dual PVC support rods, which utilizes friction to allow it to stay in place. Using a simple knob, the user can adjust the height of the fin with one turn to release or tighten the clamp. The Kanu Fin was placed under various testing conditions. It performed well and either met or exceeded 6 out of 8 target values within our acceptance test criteria. With the 2 falling short, our value stayed well within range. From our calculations and experiment, we learned that the Kanu Fin increases a canoe's resistance to tipping by 127.4%. We tested this by building an A-frame that attaches to the top of the canoe. This allows us to simulate a higher center of gravity or otherwise a paddler in the boat. A rope was attached to the frame and with the other end connected to a crane scale which read the amount of forces in Newton. Multiple pull tests were performed and calculations followed. The additional 127% resistance the Kanu Fin offers far exceeded our target value of 50%. Our client and the team are pleased with the results.